to differentiate inverse trig functions, which are of the following general form, where we have a composite inverse trig function of u of x. And here is an example. So we may have arcsine of x cubed, where u of x is x cubed. So what we do first is take the function on both sides. And on the right hand side, we obtain u. And now we can use implicit differentiation to differentiate with respect to y first, and multiply by dy dx using the chain rule, and that's equal to du dx. And therefore, using some algebra, we obtain the following result. So the reciprocal of df dy multiplied by du dx. So as you can see, if u of x is equal to x, then du dx is 1. And from here, we use trig identities to obtain an expression for df dy in terms of x. Let's evaluate the derivative of the arc cosine of u of x. So taking the cosine of both sides, and using implicit differentiation, and solving for dy dx, and now we can apply our trig identity and solve for sine y. And substituting for cosine y, which is equal to u, and taking the positive root and substituting the result into our derivative, we obtain the following expression. And as we can see, this derivative is valid where u is between -1 and 1. Here is a summary that can help you remember the derivatives of inverse trig functions. So you don't want to be applying implicit differentiation all the time, and using trig identities to obtain these expressions. So in general, the derivative of an inverse trig function is basically a function of u multiplied by du dx. So you can substitute u directly into the expression. And the derivative of arcsine and cosine differ only by a negative sign. And similarly, the derivative of arcsec and arccosec also differ by a negative sign. And so do the derivatives of arctan and arccot. So study these to learn the patterns, and you can apply them directly to practice problems without having to rederive them.